Hello class, this is a video tutorial on the equation of a straight line. In this video we will be focusing on the gradient intercept form, which looks like the following: y equals mx plus b. Now it may seem like there are four variables here, but in most equations you will see the value of m and the value of b change, and the only two we will be focusing on are y and x. In this video, all we're going to be exploring is the behavior of the equation as we change the value of m and we change the value of b. Let's take a look first at the red line. The red line is dotted. It is underneath the green one, and that equation has y equals x. So by that, when we substitute the value of 1 for the value of x, so if we put the value of 1, so take this value of x, because remember the x-axis goes along here, and the y-axis goes along here. So when we take the value of 1 and we place it into the value here, so when x is 1, y is also 1. As you can see, it has the point 1, 1. And then 2, when we substitute the value of 2, we get the value of 2 for y. Hence why that coordinate there is 2, 2. X coordinate first, y second, 2, 2. But now let's see what happens when we change the value of the gradient first. I've put a whole bunch of symbols here, and we'll go through what it means now. Let's take a look at the first one as m. So the value of m approaches infinity. Pretty much what this means, as m gets larger as it approaches infinity, the line is more steep. So here we go. If I increase the value of m from 1, as you can see, just take a look at how it moves. It's getting steeper than the original y equals x. Because remember, the red line is y equals x. So there we are. As we make the value, for example, y equals 2x, the green line is clearly more steep than the red line. So as m gets larger, the line is more steep. So m, this is 2x, y equals 2x. If we make it y equals 2.5x, it gets steeper. And as we make this steeper and steeper, this is now 3x. And if we keep moving it up, this is now 4x. That is 5x, 6x, 7, 8, 9x, and 10x. I could keep going, but you get the idea that as m increases, the steepness of the line becomes more steep. So now let's look at the second point here. When m is bigger than 0, but less than 1. I just want you to think for a moment. What is a number bigger than 0, but less than 1? Well, it'll be fractions and decimals. So when we go in between 0 and 1, so we're talking about 0.1, 0.2, or 0.5, 0.14, etc. So let's take a look now. What happens when we make this value of m smaller than 1, but bigger than 0? Take a look. There's not much of a change here. 0.99, 0.98. I'm going to start just tapping on my keyboard here so you can see it change ever so slightly. So as you can see, that as m gets closer to 0, it's becoming more shallow than the original line, y equals x. So it's much shallow. So it's not as big of an incline. If you can imagine yourself walking here. It's easier to walk on this because the stairs aren't as steep. But as we make the gradient smaller and smaller, it's getting less and less. There we are. So the closer it is to 0, the more close it becomes flat. But then, as you can see, when it becomes 0, 0.1, there's still a very slight increase. When it becomes 0, it is completely flat. So this is a 0 gradient. Now let's take a look at the next point. When m is greater than 0, the line is increasing. Meaning, any positive value for m, so just any positive value, that's positive, that's positive, that's positive, that's positive. So any value that's positive, any value bigger than 0, the line is increasing. By that we mean when we read it from left to right, when we read this graph from left to right, we can see that the line is going from lower to higher. So the values are increasing. And it's the opposite when m is less than 0. So if we go back again to the flat line here, there it is. When it's flat, there we are. You can see that when we read it from left to right, it is going downward, hence why it is decreasing. So this is a decreasing line. There we are. Oops. Fix that up. And it behaves exactly the same way. So this is more shallow than this. So this is more shallow and decreasing. Whereas this one is more steep and decreasing. So now let's take a look at the value of this one here. Y equals mx plus b. So b, oh sorry, hang on, before we continue. So m is the gradient, and it affects how steep or how shallow the line is, and whether it's increasing, so like this, or it's decreasing, like this. B, on the other hand, is what's known as the y-intercept. And I've put a little graphic here, and it shows you what the coordinates are of the y-intercept. It's called the y-intercept because since this line here is the y-axis, the y-intercept is where the line passes that y-axis. And as you can see, the coordinate, of the y-intercept will always be 0 and whatever the value is for b. I'll show you here now. So when we increase this to 1, the entire line shifts up 1 unit. And as you can see, there it is. It passes through the line, it passes through the y-axis at 0, 1. So if we increase it again to b equals 2, and there's the equation, y equals x plus 2. The y-intercept is at 0, 2. If it's at 4, y equals x plus 4, it is still 0, 4. Even if we increase the value of m, I want you to pay close attention to the y-intercept. There we go, there it is. Notice how it becomes steeper, but the y-intercept does not change. There it is. So the line is getting steeper, but the intersect of b equals 4, 0, 4, does not change. There we are. And it's the same case for when it's negative, it's moved downwards instead. So since this is negative here, so positive y values are up here, and negative y values are below. And since b is negative, the entire line is moving downwards. So just so you can see what it looks like if we change this. If this b value is negative and this b value is negative, it still passes through the value 0, -3, because the value of b in the equation is -3. So I hope that gives you an insight into the behavior of the straight line, and yeah, best of luck to you all.